Welcome. We were doing how ChatGPT can be used for linear regression. And we had seen in previous lecture that basically in linear regression, what you do is you do, there is a target variable, for example, housing price, then it depends upon two. For simplicity, we have taken two independent variables. For example, one independent variable can be plot area, another independent variable can be parking area with that house. Or we had taken here number of bedrooms, but number of bedrooms are usually not continuous. You can have either one bedroom or two bedroom or three bedroom, but 1.1935 bedrooms, that is not possible. And I wanted to make the case easier. So I wanted to have both continuous variables. So this x1 now is the plot area and x2 is the parking area. And plot area and parking area will decide y, which is the price of the house. Now, I did end-to-end complete analysis with the help of ChatGPT. So much so that I even did not take data from anywhere. Instead, I used ChatGPT itself to generate the data. So here it is the first prompt. Please create a data set which obeys assumptions of linear regression. Now, the linear regression has many assumptions, normality and linearity and homoscedasticity and all that thing. So I'm saying it that you create the data which obeys the assumptions of linear regression, which should have three column: house price, plot area, and parking area. House price is the target variable or dependent variable, and plot area or parking area are predictor variables or independent variables. Create 100 observations. Though I asked it to create 100 observations, it could create slightly less, around 67 or something, because of that limit of output. I could have forced it, but any number of observations above around 30 for demo purpose is good. Of course, larger the number of observations, more will be the accuracy of the model up to a certain limit. So our observations were around only 67 or something. That's why the performance was not that great, but still it was reasonably good. Now, I also said it that ensure that plot area and parking area are not highly correlated. Now, these it slightly misunderstood. What I wanted to say is that there are two independent variables. So, if at all they are correlated, just ensure that they are only weakly correlated. But it interpreted this statement as that not highly correlated, so it created inverse correlation between them. So that is why when I will show you the data which it generated, then you will see that bigger plot area will have smaller parking area, and smaller plot areas will have bigger parking areas, like that, which is usually a bit not very correct, but as I again said, for the demo purpose, I decided that I will go with that data. Okay, give your output in .csv format and page wise. Each page must contain 50 observations, but as I said, token limit prevented 50, so I could get around 30 observations on first page. And then I said dot 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 and page one. Here is my that first prompt, and it said certainly here is a data set which obeys the assumptions of linear regression, and it created the data set, and it is a perfect CSV file. So I just have to copy paste this, and paste it in a notepad. Okay, so this is that data. You know that CSV file can also open with Excel or notepad, but here I am opening with notepad. You can see this plot area 1000, parking area 30, plot area 920, smaller plot, parking area 35, plot area still smaller, 850, parking area 45, larger. So actually I told that ensure that the correlation between these two is weak. Say only zero point 0.3 or point, in short, it should not be 0.91 or something, but it created inverse correlation. Plot area 1030, large plot area, but parking is very small. So usually this is not a realistic data, but it is just a kind of dummy data and synthetic data which it generated. Okay. Then in next prompt, I told it that okay, give prompt 2 with next 50 observations, and it gave other observations. Now there is not much to see in that. Okay, so page 2 with 50 observations please, and it gave some more of the number of observations. And as a whole, if I show you, then total I think there were there were this time I have opened the CSV file in Excel. 57 observation. So that is a little bit too less. Ideally I should have taken still more, pressed it for still more another observations and so on. Around maybe 1,000 observations or 500 at least would have been good. But okay, fine. Now let us use this prompt 3. So I use this prompt 3 that okay, great, you have created the data set. Now give me Python code for exploratory data analysis, EDA, and data is stored in this file, housingdata.csv. Give code for Jupyter Notebook. This time I explicitly told it that give code for Jupyter Notebook, and even that much was not enough in my earlier trial. So I even had to specify that instead of print, use display. Okay, start with, still it missed something. I will show you what it missed. Start with import of libraries, include code for viewing top 10 and bottom. So this is what to do in EDA. That also I very clearly specified that give me head, but head will give 5 rows and tail will give 5 rows from bottom. So I wanted 10. So I told give me code for 10 rows from top and bottom. Then heat map, correlation matrix. Now I forgot one thing, summary statistic. So it also, ChatGPT also forgot summary statistic, but summary statistic is always quite important thing. So I had to give. Then give code for outlier detection using box plot and histogram, and Python code for doing EDA by pandas profiling also. So this much was for step by step EDA, as we have seen in the previous lecture. And this is also we have seen in the previous lecture that Panda has that built-in profiler which creates EDA in a few seconds, and that is also quite useful. So this is where that prompt was used. Okay, also give me code by Pandas profiling, and it gave this code. Now, what happened with this code is that since I had specified very clearly that I want code for Jupyter Notebook, then perhaps, yes, display it used, but to display some library is required to import. That it forgot. As a result of that, my code was not displaying anything. So I had to tell it that in the above code, display statement does not generate output. So do we need to import a library? So it immediately apologized and then imported one library like this from ipython.display, import display. And then rest of the code is same. And I used that code And let us see how our Jupyter notebook does. I am deleting all outputs. Yes, and we start from the beginning. So importing library, reading the data in. Summary statistic, as I said, it forgot because I forgot to give it in the prompt. So sometimes it forgets, sometimes it automatically remembers that summary statistic is a part of EDA, exploratory data analysis. So this is the summary statistic. House price has this minimum, maximum value, mean value, and count is 56, and all these things. Okay, view data, head, top 10 rows. So these are top 10 rows. Since I asked it to specifically create a good data, so there are no null values or none, but in practical data set which come from real life, none are there and you have to do something. Now here is what I was saying about that correlation. So I told it that there should not be big correlation between plot area and parking area, but it actually gave this kind of situation that house price is and parking area 0.89, plot area and parking area, this is minus 0.9. So they are inversely correlated. And therefore, even house price is also inversely correlated with parking area. So that means the houses which have less smaller parking, they will fetch more value, and houses which have larger parking, they will fetch less value according to this data. So actually it is not a realistic data, but one important training for data scientists is that never use common sense. Whatever data is given to you, you have to remain honest to it. You cannot change the nature of data, and you have to give your interpretations based on data. So let the data speak. That is very important rule. Okay, then pair plots I want to show. Now these pair plots are important because I had said in the prompt itself that give me observations which obey the assumptions of linear regression. And you can see that house price and this variable plot area, the data is very nicely distributed so that I can easily fit a straight line, that too almost passing through origin. But here this reverse correlation created some problem. Again, I can nicely fit a straight line, so linearity is obeyed. But due to the reverse correlation here, there would be a big intercept on y-axis. But that is because of that misunderstanding. I could have clarified it and asked it to generate a better data. But the point is, data is nicely linearly distributed. That much you can see. Okay. And now outlier detection using box plot and histogram. Here also it forgot to give, it gave box plot for the house price, that is the target variable, histogram for the house price, box plot for the plot area, histogram for the plot area. But it did not, it completely forgot about the other independent variable, that is parking area. So I had to remind it. Here you can see the in above code in the section outlier detection using box plot and histogram, there is no code for plotting box plot and histogram for the column parking area. Can you please correct it? So this time it apologized for the oversight, and this time it generated this code. Mm, this. Now you can see that there is a box plot and histogram for price, this and this, then box plot and histogram for plot area, and then box plot and histogram for parking area. So I had already added manually because I knew that there is another variable, and therefore, so let us plot them. there are not likely to be any outliers. Outliers usually, this is called median value, this black line. Here, this is the median value for plot area. Okay. So, and this is the median value. Are usually the values which are even beyond this limit, somewhere far away. Okay. And here also somewhere far away. But here, the data itself was generated nicely such that it obeys the assumptions of linear regression. So it did not give any outlier, which was a relief for us. There is no need of removing outlier or doing some kind of outlier treatment. Okay, that give me code for doing test train split. Because when we saw these particular uh, then we saw that in machine learning how we to find this value. Mathematically, you can find the values of this beta 0 and beta 1 and beta 2, and then price is equal to this is beta 0 plus beta 1 multiplied by plot area plus beta 2, this value multiplied by, here in my our case, parking area, not number of bedrooms, right? So you can find mathematically, but by machine learning we don't do it. We have done it that we divide the data into around 80% to 20% or 70% to 30%, like that. uh, the larger one is called train set, while the smaller one is called test set. Then we train the regression algorithm on the train set. Then we test that model which is created by training on the train set. We test it on the other remaining observations which were not used in the training. And then we predict y using x1, x2 and the model. Okay. So then this is how it is done. Now let us give this prompt. So I want to first split my data set. So for that I gave it this. Yes. Give me code for doing test train split. So test train split, and it imported this sklearn model selection. Import from that, import train test split, and then this is standard way of splitting a data set, which everybody who has done a little bit of machine learning with Python, they know that. And then train data shape and test data shape. Again, it gave print suddenly. It forgot that we are doing for Jupyter notebook. But I modified that code and I give it display. Okay. So yes. So I have a small train data set and even smaller test data set. And the ratio was 70% in the train data and 30% in the test data. So zero point 0.3 is the test data size of 30%. Now, then I want to do the next thing even that we have done just now. Then here continue the code after creation of train set and test set, and I want to use linear regression model for training of the train set. And then I want to use the trained model to predict on the test set. Please give Python code. So it generated this. Now, when it generated the Python code, this is how X train and X, Y train are created. Train includes both independent variables. Y train includes the dependent or target variables which we want to find. X train includes both independent variable or predictors. X test also includes predictors, and Y test includes again target variable or dependent variable. Okay. Now then linear regression model is created in this manner and it is used for fitting. This is called training of the model. On the train data, you can see we are using both train only. Okay. Then using the trained model, now this is the model. Linear regression model is equal to linear regression model, and then linear regression model dot fit. Now linear regression model, the fitted model is used to predict, but on unknown data, that is the remaining 17 or etc. number of observations which were not used in the training. Training was done on these two, while testing is done on this. Okay. And though I did not ask anywhere in my prompt that gives some metrics for the performance of my model, how accurate my model is, it automatically generated this metric. However, when I try to use this code as it is, this mean squared error did not work because it requires importing of one library. So actually speaking, we were here, yeah, separating the train and test. So X train, Y train, X test, Y test. Now creating the linear regression model and fitting the model on the train data. In short, this is how the training is done. Now that trained model, now it is, this is the trained model. In the previous step, it was trained, is used to predict the value on unknown data, X test, okay. And then this statement it had missed actually, that import mean squared error. As a result of that, suppose I don't execute this and everything else was correct, but it will, okay, I think it is already imported earlier in my earlier execution. So fine. But otherwise it gave error that there is unknown name error means squared error. So I had to then ask. So I am behaving as if I don't know anything. Okay. I knew that mean squared error requires importing, but I said that it gives this error. Mean squared error is not defined. So it said apologies for the oversight. Mean square error function is part of sklearn.matrix. So you need to import this. So from sklearn.matrix, import mean underscore squared underscore error. And then the code worked perfectly. Then I asked it any other matrix, okay, like r squared. So it says that for linear regression, we usually use mean squared error and square root of it, which is called root mean squared error and r squared. So earlier it had only given the code for mean squared error, MSE, but I asked it that give me code for other matrix. So this time from sklearn matrix, it not only imported mean squared error, it also imported mean absolute error and r square. Okay. And then it gave this code. When I executed that code, this was the mean absolute mean squared error. This was the root mean squared error. Now it looks from this much only that it is not exceptionally good model, because if you see the price, then 2,15,000, 2,15,000, yes. Then this is 2,30,000, somewhat around 2 lakh. In 2 lakh, that is, we are predicting values which are around 2 lakh. In 2 lakh, this is the error around 8,000 rupees is the error in the predicted price, which is, well, not very big also, but not small also. Then this is mean absolute error, and R square is 0.79 or 79%. This R square should be as high as possible. Normally, if you try proper data and use certain things, for example, we have not yet normalized this data. If you see this describe output, then the minimum and maximum value of this, that changes quite in a big range. Minimum and maximum value of this changes in a moderate range, and minimum and maximum value of this changes in small range. So that it means I should apply that min max scalar, if you remember from previous lecture, so that these also has minimum and maximum value 0 to 1. These also has 0 to 1, and these also has 0 to 1, which is called normalization. That might improve the performance. And most importantly, I should create a realistic data. This data itself is not nice in the way that smaller parkings means larger house price, and larger parking 40 has a smaller house price, while smaller parking 31 that has larger house price. So it misinterpreted my prompt while generating the data, and it is a synthetic data, so it is okay. Now I wanted to find those beta 0 and beta 1 and beta 2, because what if I am given a completely new observation in which I am given x1, that is the plot area, and x2, that is the parking area, and I am asked what will be the price of that house. So then I should have the constants. So I gave another prompt. If you remember, last time it had generated coefficients on its own. This time I had to specifically ask that how can I find coefficient of linear regression? And it gave me the coefficient, that this is how coefficient can be found. Again, in previous case, it generated coefficient as well as the intercept in single go. But this time it generated only coefficient. So for intercept, I had to ask a next question, how to find intercept term. And then it gave me the code for coefficient as well as intercept term. Okay. So I incorporated all this code, and here this is the coefficients are this, and intercept is this. So housing price is this value. I have kept only 2 digits after the decimal point, rounded off, plus this is beta 0 plus beta 1, that is this first coefficient, into the value of that first independent variable, plot area, and beta 2, that is the other coefficient, it is negative, and multiplied by parking area. As I said, that negative does not make much sense, because that will mean that bigger parking area will have smaller price. But that is how the data was generated, and I cannot change the data. That is the basic tenet of data science, that whatever data says, that is final. Okay. Now then, this particular thing is such an equation, this is itself in common language called model, that if I am given a plot area and parking area of some totally different uh, plot, and I am asked that what will be the price of house if house is built in that, then I can predict using this equation, because this is a constant. So just plug in plot area and parking area. Okay. So this is how end to end you can do. We have generated data, we have done EDA, exploratory data analysis, and we have also done performance evaluation, and we found R square, etc. 80% R square is not exceptional model, but it is good model all the same. And then I also asked in one more prompt that give me the code for giving summary statistic using pandas profiler. So I don't. No, I think, yeah, here it is import pandas profiling, and then somewhere it must have used EDA using pandas profiling. Then it must be there in my uh, Jupyter notebook also. I just avoided. Ah, yes, it is here. So you can see how fast pandas profiling is working. And it generated the report. If you see the report, it was generated in just less than 2 seconds. And it gave some alert that these are highly correlated, these are highly correlated, these are highly correlated. Also, there are 17.9% duplicates, but that is okay because house areas, etc., cannot have much variation. So you should not remove duplicate rows blindly. In some data sets we do that, but not here. Okay, then for each column you can find this is for house price column. Then you can do for our plot area column, and this is for parking area column. Okay, how many distinct values are there, how many missing values are there. It cleverly generated a code in which there were no non values, so there were no missing value, and histogram is plotted. This is the scatter plot for the price versus parking area. And as I said, it is inverse correlation, though nice linearity is there, but it is inverse correlation. And if had this inverse generated heat map also, uh, again you can see the correlations, and wherever there is red color inverse correlation minus near -1, and blue color dark, so positive correlation. Then these are the count, and these are the metrics. And first 10 rows, last 10 rows. Is advised that one should